Good afternoon, dear students. Yesterday was our previous lesson, and we were working with the straight line in the space. And today we will sum up everything in analytical geometry. Basically, not the whole analytical geometry, but uh, uh, planes, points, and straight lines. So today we will solve tasks related to mutual locations of points, planes, and straight lines. Okay, I will remind you some theory. So how to find an intersection point of the straight line that we did yesterday. So we need to solve to these equations. So equations of the straight line and the plane. Then how to find the angle phi between the straight line and the plane. So we can find the sine of phi. So we divide magnitude of scalar product of normal and direction vector and divide by product of normal and direction vector magnitudes. So parallelism condition of the straight line and the plane. So a scalar product of normal and direction vectors is zero. So they are perpendicular. So what basically it means. And straight line perpendicularity condition is the following. So coordinates of normal and direction vector are proportional. So that means that normal and direction vectors are collinear. How to calculate distance between the point and the straight line? So yeah, it was on the previous lesson. So the following formula. So we divide magnitude of cross product of vector AM, where M is not doesn't belong straight line. So we divide cross product of vector AM and direction vector by the magnitude of direction vector. And again, reminding you the condition of for lines line in the same plane. So direction vectors and vector based on points that belong this direct straight lines. So they must be coplanar, and that's its condition. And the distance between skew straight lines. So we divide magnitude of the mixed product of this vector by the magnitude of cross product of direction vectors. Any questions for now? Okay, as I see no questions, so let's start solving tasks. Task 1 is similar to the last task on the previous lesson. So, but on the previous lesson, we had to find a projection of the point M on the straight line, and today we are looking for projection of the point on a plane. Solution is analogical. First of all, let me draw a little bit for easier understanding. Okay, so here is too thin. Here is point M, yeah, and this is the plane Q. And this is a projection of point M, let we call it N. And how to find this projection? So we need first of all first of all we need to find a perpendicular, so the straight line that is perpendicular to this plane, and n will be the intersection point of this straight line and the plane. So it will be the projection that we are looking for. Okay, now let's start. So, first of all, we need to write down the equation of the straight line L. How to find? Do we have everything for that? So it passes through the point M. What else do we need?
Direction vector.
Yeah, and how to find it?
We have it from the space Q. 2 minus 2 and 10.
Yeah, we can use 2 minus 2 and 10, but we can reduce it for easier calculation in the future. So we can divide it by 2. So I can move 2 out of brackets. And direction vector will be proportional to this vector, to the normal vector. So it doesn't always mean that we need to take the same, but it can be proportional. So less numbers, easier calculation, usually. Okay. So the equation of straight line L is the following. So x plus 2 by 1 equals y by minus 1 equals z minus 3 by 5. And now we need to solve the system of equations, the following system. Okay, so let me rewrite it. So as before, so we need to rewrite canonical equations to parametric form. So what we will receive finally. So x equals t minus 2, y equals minus t, and z, yeah, so z not t. I will erase it and write correctly. So z equals 5t plus 3. Now let's substitute. So 2 by t minus 2 minus plus 2t and minus and plus 10 5t plus 3. So 2 plus 2 plus 50, so 54t minus 4 uh, No. Yeah, and +1 forgot it. And it's important not to lose all coefficients. So minus 4 plus 30, so 26 plus 1, so 27. Yeah, so good numbers. So t equals -1 second. So and x, so x equals, so t minus 2, so -5/2. Y equals 1 second, and z equals so minus 5/2 equals 1 second. So coordinates of the point N are the following. And let's check the answer here. Yeah, here I didn't reduce the direction vector, but we received the same result. Yeah, decimal numbers instead of usual, so ordinal fractions. But anyway, that's okay for us. So it means the same. And now we need to find point M symmetric to the point M, relative to the plane Q. So where is it located? Where should it be? How to find it? Any ideas? So analogically that we were doing it yesterday. So are these segments equal? Yeah, go on.
They are equal. We can find the like m prime from the middle point formulas.
Yeah. So N is the middle point, so let's go with this. Okay. So I will write first of all formula of finding the middle point. Oh, by the way, here are coordinates of M. So xm plus xm prime by 2. So xm prime equals 2xn minus xm. So minus 5 plus 2, minus 3. So analogically y. No. So y, so 1, okay, it equals 1. And that. So 1 minus 3, so minus 2. Yeah, so correct solution. So finally, point M prime has coordinates minus 3, 1, minus 2. Any questions about this task? Okay, as I see no questions, so continue. Solving. So the next, what we have? So we have the equation of the plane P, P1, straight line L1, and point M. Maybe it's redundant copy and paste, but anyway. So, okay. So let's start solving. So a lot of points here, a lot of parts that we need to perform. So equation of the plane P2 passing through the point M parallel to plane P1. How to solve? What do we need for it? So we have point M that belongs to P2. What else do we need? No ideas. Well, so we need a normal vector and for the plane P2, and it is equal for P1 because plane P is parallel to P1. Five, 0, 3 coordinates of this normal vector. So what we have for P2, 5 x minus 2, skipping y, plus 3, 0, or plus 3z equals 0. So finally, 5x plus 3z minus 10 equals 0. And that's it. So now we need to find the equation of the plane P3 passing through the point M perpendicular to the straight line in L1. So how to find the normal vector here of the plane P3? So we have the point, we need only normal vector. So as it is perpendicular to the straight line L1, it matches its direction vector. And has coordinates 1, 2, and 3. So let's write the equation. So x minus 1, or x minus 2, plus 2y plus 3, and plus 3z equals 0. So let's expand it. So x plus 2y plus 3z. So minus 2 plus 6 equals 4. So plus 4 equals 0. So found it. Then part C. We need to find the equation of the straight line L2 passing through the point M perpendicular to the plane P1. So we have the point, we need to find direction vector. And what will direction vector be equal? So, any ideas? Sophia?
To normal vector, like from P1.
Yeah, normal vector of P1. And yeah, I would ask colleagues to join discussions as well. So to make them more interesting. Okay, so writing down the equation of L2. S2. Yeah. So x minus 2 by 5 equals y by 0 equals z. No. So y plus 3. Yeah, confused vectors, coordinates. So equals z by 3. So that's it. And for part D, so we need to find the equation of the plane of the straight line L3 passing through the point M, and it is parallel to the straight line L1. So the direction vector of L3 matches L1 because it's parallel. So it equals 1, 2, 3. And now let's write it. So x minus 2 by 1 equals y plus 3 by 2 equals z by 3. And that's it for these equations. And now we need to find the distance between point M and the plane P1. Okay, I will remind you the formula for this distance. So, formula is the next. Sophia, yeah, question?
We skipped E.
Yeah. Okay, we will return to it. But thank you for your attention. So, 5 by 2 plus 0 by minus 3 plus 3 by 0, nice, minus 7, and divided by the magnitude of normal vector. So 25 plus 9. So 10 minus 7, so equals 3. And 3 divided by square root of 34. Let we check it. Yeah, so 3 by square root of 34. Okay, and let's now return to part E. So find an intersection point N of the straight line L1 and plane P2. So doing the same that we did before. So in the previous task, so for more practice, so x equals t. I will write it faster. So y equals 2t plus 1, and z equals 3t minus 1. So substituting into the equation, I even need to extend the space for creativity because running out of it. So 5t plus 3 by 3t minus 1 minus 7 equals 0. So we need relative to t. So 5 plus 9, 14 t minus 10 equals 0. So t equals 10 by 14, it equals 5 by 7. Yeah, so we can reduce it. Okay, let me just let me not calculate these fractions. So I believe you will forgive me it. And so just let's believe that everything is correct here. But by the way, if we verify quickly, so 5 by 7, so 14 plus no, 10 plus 7, yes, 17, and 15 minus no, no. 15 minus 7, yeah, 8. So everything is correct. Okay, and now let's find the distance between, so the distance between the point M and straight line L1. So vector M, so AM, so coordinates of A can be the following. So they are the following. So A has coordinates 0, 0, 1, and minus 1. And it belongs L1. So coordinates of the vector are the following. 2, 4, minus 4, 2 minus 4, and minus, by the way, 2 minus 4, 1. Yeah, so now everything is correct. So, again, running out of space for creativity. So, large task. So we need to, first of all, to find the cross product of normal vector of the direction vector S1 and this vector AM. Yeah, but remember that anti-commutative cross product, so it means that the order is important. Okay, but we skip calculating this cross product. So it has coordinates. Yeah, by the way, so here is we have such order and in our case inverse. So we have other sign. So 14, 5, minus 8. So by the way, magnitude won't change. It will be the same. So basically, what are we having? So the formula is the following. So we need to find, so we need to divide magnitude of this cross product by the magnitude of direction vector. So found magnitude of cross product, found magnitude of direction vector, and divided it. So such not understandable number, but result is adequate, so it's greater than 0, so it's non-negative. Any questions about this task? Any points of this task? If not, moving to the next task. So we have yeah, a lot of things to do as well. So we have a pyramid with the coordinates of vertices, and we need to solve some tasks related to this pyramid. So first of all, let's draw it for better understanding. Okay. And which coordinates it has? So yeah, let's name them correctly. So uh, uh, okay, A1, would it be A1? Maybe ABCD would have been more understandable, but anyway, let's use this coordinates, this naming. A3, and it will be A4. So now the first what we have to do is to find the equation of straight line L passing through points A1, A2, and lengths of this edge. So basically, what so how to solve it? How to find the equation of the straight line? Any ideas? So we have 2 points. Is it enough to write down the equation of the straight line? Yes, it's enough. So let's do it. So we have 2 points. So equation of the straight line passing through 2 points is the following. So here, so subtracting coordinates of the first point. So x minus 3 minus 2 by 5 minus 2 equals y plus 1 by 5 plus 1 equals equals y, oh no, not y, z minus 1 by 4 minus 1. So if we simplify it, we will have the following. So 3, 6, and 3. We can even more reduce it. So we can multiply all parts by 3. It can be simplified because less numbers, easier calculation in the future. So here is the final form of the equation passing through points A1 and A2. Then, so what we need next? We need to find length between A1, so length of this edge, A1, A2. How to find it? It is the magnitude of the vector A1, A2. So basically that's it. But what we can even simplify it. So this is the magnitude of 3 direction vectors S. So moving 3 out of the magnitude. So 3 by 1 plus 4 plus 1, so 3 square roots of 6. So this is the length of this edge. Then part B. We need to find equation of the plane P passing through points A1, A2, A3. So this plane on which this face is aligned. So how to solve? Do we have everything, enough information for us? Yeah, enough because we have the coordinates of 3 points. So let's write it on such a form. So, by the way, I have coordinates here. So x minus 2, y plus 1, z minus 1. So 5 minus 2. Not understandable number. Now let me write it better. So 5 minus 2. Then 3 minus 2. 5 plus 4. 5 plus 1, 2 plus 1. Then 4 minus 1. And minus 1. Let me double check it. Of course. So x minus 2, 5 minus 2, 3 minus 2. Okay. 5 plus 1, 2 plus 1. Correct. 4 minus 1, minus 1, minus 1. Okay. And now let's simplify it. But maybe, yeah, let's simplify it. Because we will need some information here. So that's what we have. Okay, and what we basically what we skip calculating this determinant. So this is the final equation of the plane. So this step is correct, and there we just need to calculate the determinant and expand brackets, and here is the final. So the general equation of the plane P. So minus 7x plus 3y plus z plus 16, and it equals 0. And also we need to find the area of ABCD face. So how to find it? What do you remember about it? So how can we solve? So so nobody else wants to join discussion. Okay, Sophia, go on.
This is 1 second of the cross product of A1, A2, and A1
Yeah.
and 3.
Correct. So A1, A2, and A1, A3. Yeah, cross product of the magnitude. And A1, A3. Yeah, of course we can choose any other vectors, so it won't affect the results, so A2, A1 or A2, and A2, A3, but we already have coordinates for these vectors. So A1, A2, this row, and A1, A3, this row. So now it's, yeah, incorrect form. So now it's correct. Okay, now let me just copy and paste some recordings. Uh-huh. Okay. Okay, and if we calculate the determinant, just no, believe me. So this is the determinant will be the next. Yeah, so the product, cross product, so minus 21, 9, 15. And the magnitude is the next. So, and when we uh, uh, so when we put everything together, so S will be equal 3 by 2 square root of 83. So not understandable number, but adequate number. Okay, and then we need to find the equation of the altitude h dropped from vertex A4 on the face A1, A2, A3. So let's draw it first of all. So forget our palettes every time. So here is the altitude. So straight. Okay, so what we mark it here, yeah, and we also can name this point M. I'm not sure if we will need it, but what we do it. So the equation of the altitude h, how to find it, this altitude. So what do we need? What do we have? Do we have everything, or we need to perform some actions for that? So any ideas? Okay.
Well, I
Bogdan,
think
yeah.
we need point M.
We don't need point M. So we have the point that passing through this straight line is passing, and what else? Yeah, we don't need point M. We already can use direction vector, but so we already found it, but not as the direction vector of this straight line, but uh, another usage of it. Sophia?
We know that the direction vector of the altitude equals to normal vector of the plane, and that's why we can construct the
Yeah.
equation.
Yes, so let's do it. So that's just what we needed. There is no need to find m, but anyway, yeah. So first of all, we would have had to find. Okay, so we don't need m for now. So, mm, uh, direction vector of s of h is so matches normal vector of the plane P. So it is the following: -7, 3, 1. Okay, so -7, 3, 1, and now let's just write down the equation of h. So point A4 belongs it, so x minus 4 by -7 equals y minus 1 by 3 equals z minus 3 by 1. So this is the equation. And how to find the height of the magnitude, so the length of this altitude. So any ideas? Your suggestions? Really, no suggestions? Okay, so the first way is to find the intersection point M of the plane and this straight line H, and then find distance between M and A4. But there is a simpler way to do it. Bogdan?
We could find the intersection point of the height with the plane, I think.
Yes, but yes, we can do it, but there is a simpler way to do it. So we have everything for that. Sophia, your suggestions?
We pick the point A4, and it will be like we find the distance from this point to the plane.
Yes, so we have enough information. So in such case, we don't need coordinates of the point M. So basically, it's odd. So, про всяк випадок намалював. Okay. So yeah, but anyway, thank you for involving. So I want more people to take parts in discussions. Yeah, because I like talking with clever people. So yeah, finding it as the distance between point P and M. Not M, A4. So it is the following. So -7 by 4 plus 3 by 1 plus 1 by 3 and plus 16. And here 49 plus 9 plus 1. So again, strange irrational numbers. So just let's believe these recordings. So found it. Then we need to find the volume of the pyramid. You saw the spoiler, but I guess you have known it before. So how to find the volume of the pyramid? Okay, I started, but I want to hear anybody else. Well, you are so shy, so let me write. So it is 1/6 of the magnitude of vectors that build this pyramid. So magnitude of vector. So vectors. So we calculate the mixed product of vector a1, a2, a1, a3, a1, a4. Then we divide the magnitude by 6. So, okay, let me copy and paste this values. And then, so 4, 4 minus 2, so 2, 1, so 1 plus 1, 2, so 3 minus 1, so 2, 2, and 2. And again, we will skip calculating the determinant, so minus 18. So finally, the volume is 1/6. So by the magnitude of 18, and it equals 3. So this is the volume of the pyramid. And let's calculate a couple of angles, and after that we will have a break. So angle between edges A1, A2 and A1, A4. So let's find the cosine of so cosine between these angles. So A1, A2. So finding scalar product. And dividing by the product of the magnitudes. Okay, so coordinates of A1, A2. So what we have, so 6 plus 12 plus 6 by, so by the way, the length of A1, A2 was 3 square roots of 6. By okay, square root of 12. And let me not play with these square roots. So our cosine, so the cosine of this angle is the following, and alpha is not, so it's not a table value, so just such irrational number are cosine of this number 4 by 3 square roots of 2. And then we need to find the angle beta between edge A1, A4 and this face A1, A2, A3. So it can be received as yeah, we first of all find in a sine of beta. So it's magnitude of scalar product of the plane, so of a normal vector of the plane P and vector AM, A2. Oh, A1, A1, A4 and N, NP. And of course, their magnitudes. Okay, and as well, let we not play with these values. So again, so irrational number, square root of 3 by 59. So beta has the following value, arc sine of square root of 3 by 59. Any questions about this task? If no questions, let's have a break for 5 minutes and then we will continue. let's continue. So the next task, we have two skew straight lines, L1 and L2, and we need to write down equation of their common perpendicular. Well, we won't pay a lot of time with calculating everything, so better we'll spend some time with understanding how to solve, basically. So we need to draw. So let's draw two skew straight lines. So they are not, so they don't intersect. Let's imagine that this is 3D, 3D space. So they don't intersect. And they have the common perpendicular. So let me draw it. But first of all, I will mark planes. So L2. So the common perpendicular will be the following. So let me draw it here. So, and I will mark it as H. And that's not an intersection point, just it looks like that. So we need to find equation of this intersection of this common perpendicular. Any ideas how to find it? Well, that's basically not so obvious. So first of all, so how to solve? We need to draw more items here, and then I will explain the idea. So here is the plane Q. What we mark that. So that the plane Q that passes through the plane L2 and parallel to L1. So L2 belongs Q, and Q is parallel to L1. So it's important. So we have only one such plane. We can find this this plane, and any ideas how to find it, how to find the normal vector of Q. So we have a direction vector for L1, it's S1, and direction vector for L2, S2. And yes, Sophia?
Normal vector will be a cross product of this directed
Correct.
vectors.
Yeah, so we found the plane Q. Okay, so we have everything for the plane Q, so we can take, so we have the normal vector and the point that belongs Q. So this point can be found from the equation of the straight line L2. Then, after that, we need to find other two planes. I will explain you which planes. So, so plane P1 and plane P2. So what these planes? I'll explain in just a moment when I finish drawing, of course. Okay, I just want to believe that this figure is understandable, looks understandable. So here is the plane P1, and this is the plane P2. So what we know about planes P1 and P2? So L1 belongs P1 and L2 belongs P2. So they pass through these points. They pass through these straight lines. And what else? Both these planes are perpendicular to plane Q. So we need to find planes P1 and PQ and P2. So equations of these planes will be the final answer for this task, because with these planes we will receive the equation of so the general equation of this straight line H. Because it is the straight line by which planes P1 and P2 intersect. Questions about it, how to... So, any questions for now? That's not
No.
the end of the task, by the way. Okay, so continuing. For these planes, we need to find normal vectors. So for P1 and for P2, we know points that belong these planes. So finding in them from equations of straight lines L1 and L2. So how to find N1? We know direction vectors of L1 and L2, and we know normal vector of the plane Q. So how to find normal vector of P1? Okay, no ideas. So I will explain. We need to find a cross product of vector of normal vector of the plane Q and direction vector of S1. So, and it will be so yeah, maybe yeah, if I'm understanding correctly, yeah. So it will be the yeah. So it will be cross product of direction vector of L1 and normal vector for Q. And normal vector of the plane P2 is the cross product of the direction vector for L1 and for the plane Q. But by the way, let we draw it. Let we draw these vectors. So this is N2, N1, and this is N2. And yeah, we can see that N1 is perpendicular both to NQ and S1, so from cross product. N2 is perpendicular to S1 and NQ together. So as well, this is the cross product of these vectors. And now with the normal vectors of these planes and points that belong these planes, we can write down equations of these planes. So for plane P, we have such equation. So M1 is taken from the equation of L1, this point, and found, no, yeah, so this is for P1. So M0, M1 took from this equation, and N1 we found, and we have such a plane. Analogically for P2, so M2 is taken from this equation, -1, -1, 2, and normal vector finding as a cross product. And with the equations of these two planes, we are writing the general equation of the perpendicular H. So the task is to find the equation of the common perpendicular, which from canonical, general, parametric, it doesn't matter. So general form can be transformed to other forms. Any questions to me about this task? Yeah, it's not, it can be complicated, but yeah, in this case, drawing will be more helpful than just trying to solve it with the formulas. So it's hard to imagine just in your brain. Okay, there's no questions for now. Let we solve task number 5. Cleaning the board. So we have the plane P and the straight line L. So first of all, we need to find the sine of P of the angle between P and L. So, well, you see the formula, but okay. So phi will be the angle. So sine phi is the next. So 1 over 1 by square root of 15. So we just finding sine and that's it. So we don't extract angle. Then we need to find intersection point n coordinates. So L doesn't belong P, so not correct symbol, must be like that. But okay, so like this. That's not critical. So we need to find the intersection point and coordinates. Well, let's start solving. So x plus y minus z plus 1 equals 0. So let's write in parametric form. So x minus 1 by 0 equals t. Yeah, so transferring to it, y by 2 equals t. Z plus 1 by 1 equals t. So x equals 1, so it is always constant. So it means that each coordinate of So each point on the plane L has x coordinate as 1. So that's just what does this 0 mean. So we don't divide by 0. It means just that coordinate is constant. Y equals 2t. Z equals t minus 1. So 1 plus 2t minus t plus 1 equals 0. So t equals minus 2. And what we have, so coordinates of the point n, okay, I don't remember, but where to write it? So 1, so 2t minus 4, and z t minus 2, so minus 3. So found coordinates. Oh no, something is not correct. Yeah, because I forgot square root. Oh, not square root, plus 1, so 3, remember. So classic problem. So let me correct it. So 1 minus 6 and minus 4. And these are coordinates of point N. Then we need to find equation of the plane Q. That is so passing through the straight line L perpendicular to the plane P. Okay, let me. I forgot just to move it up. Okay. It's not so good, but yeah, let's move it up. And that's it. So L belongs Q, and P is perpendicular to the plane Q. And what does it mean, basically? Yeah, but let's write the general equation. So AQ plus BQ yeah, AQX plus BQ Y plus CQ by Z plus DQ equals 0. So, what we know from this? So AQ, yeah, so normal, so as these points are perpendicular, so normal vector of P, so a scalar product, and no scalar product of normal vectors is 0. Normal vector of the P is the following: 1, 1, minus 1. So this is the next. So what? By the way, yeah. Oh, we don't. Yeah, we don't need D here. Sorry. Yeah, so we can set it to 0. It's okay. So AQ plus BQ minus CQ equals 0. So that's what we know. What else? Yeah, we can write dz, but it will be, we need to find coefficients A, B, and C. What else we know? What can we receive? So it is also, so vector S of the straight line L is perpendicular to the normal vector of Q. So it means that their scalar product 0 as well. And coordinates of the direction vector are the following: 0 to 1. So that's the first equation. And the second, so 0 AQ plus 2 BQ plus CQ equals 0. And then we will have the homogeneous system of two equations with three variables. So the following system. And we have to find the coefficients from it.
I'm sorry.
Yeah,
Plus
thank you.
CQ.
Yeah, thank you for your comment. Yeah, for your attention. It's important not to lose science. So, C will be a free variable. So, B is the following. So, B equals minus 1 second of C. A equals so minus B plus C. And so it equals minus 3 second of stop. Yeah, or just 3 second of C. So now what do we have? So we need to take C that so we need to take C that is more convenient for our solution. So which value do you suggest to assign to it? Any suggestions? I would take 2 because so to eliminate these fractions, so to receive whole numbers. Then AQ will be equal 3, B equals minus 2. So the equation will be the following. So 3 by, yeah, we need also to select to use the point. So we have normal vector and the point. So 3 x plus 1, no, x minus 1, by the way, yeah, minus y and plus 2 z plus 1 equals 0. Yeah, and if we expand, so 3x minus y plus 2z equals, so 2 minus 3, yeah, So minus 1 equals 0. And this is the equation of the plane Q. And the next, we need to write down the equation of projection L prime of the straight line of the plane P. We are running out of time, so I will just show you how it's calculated. And you have this material. So, we need to find direction vector of the projection. It can be found with such formula. So we subtract. So from direction vector, we subtract normal vector of the plane multiplied by scalar product of direction and normal vector, and divide by square magnitude of normal vector. And after that, yeah, of course, yeah, we have the plane, the point P, point N that we found before. So with the direction vector and the point, we write down such equation of L prime. Any questions about this task, previous tasks, previous lessons?
No questions.
Okay, no questions. So now let's finish. Have a nice day. Stay safe. Thank you for your attention.
Thank you for the lesson. Goodbye. Have a nice day.
Goodbye.
Thank you so much.
for the
Goodbye.
lesson. Take care.